Okay, this video is the second installment of the Power Rule Practice Lab 1. And just to show you, this is what we worked on the first time is you guys had to do 3 through actual 40. So we practiced some of this. And then I actually did 39 and 40 in in-class practice number 12, which has a video. And then today I did in class practice 13, which is those. And then you were responsible from 51 on down. And I scanned these in from a different book, so they skip around. So what I did was the ones that are circled in yellow, I actually going to explain. The ones that are circled in black, you need to finish. And you don't need to do 55. So I'm going to do 52, 53, 54 in this video, and 57, and 61, and 63. We'll see how long this goes, all right? So I'm going to start doing this. So as I do this, I kind of copied part of the problem down, but if you really need to come and see it, it's there. So I'm just going to start a couple. So here's 52, and they basically have this function for 52, and then they want you to find f prime of r equals 4. So basically what you want to do on this one is take the first derivative and then put it equal to 4. So I'm going to do f prime of x here. And when I do f prime of x, the derivative of 13 is 0. The derivative of negative 8x is minus 8. And this is going to be plus, then it's going to be 2 radical 2x. So when you bring the 2 down, some people say radical 4. Just be careful. It's 2 radical 2. And then we're going to put this whole equation equal to 4 because I want to solve for what that would be. And I look at this here, so I'm going to add 8 to both sides. So I have 2 radical 2x equals 12. Divide by 2 radical 2. So I have x is 12 over 2 radical 2, which reduces to 6 over radical 2, which if I rationalize it, radical 2 over 2, that's 6 radical 2 over 2. Divide those out, comes out to be 3 radical 2. So I know I kind of did that fast. If you need to slow this down or try it yourself to see if you come up with the same answer. But I wanted to do that one because they threw some r's in there, and basically that's all they wanted you to do is find the first derivative and put it equal to 4 to figure out what value would give you that. The next one we're going to do is 53, and if you need to look back at it, 53 basically says find the equation of the tangent line to the graph of f at the point 1, 1. So they gave you the entire point, and they want you to find the tangent line. So the first thing is I copied down my problem. They gave me the point 1, 1, and I copied down the point slope form to say, okay, what do I need? Well, I need a point and a slope. Well, I do have my point. So I know I'm going to throw a 1 in here eventually and a 1 in there eventually. I just have to find the slope, which is the first derivative. So when I do this, I'm actually going to plug in the 1 when I'm done. So I'm going to do f prime of x equals, and I do the derivative, so it's going to be 6x squared minus 4x, and that would be 0. And then I want to find the slope at 1. So I'm going to plug a 1 right in this spot right here. So I have f prime of 1 equals 6 times 1 squared minus 4 times 1, or 2. So my slope is 2. So the 2 is going to go here. So I know my line is y minus 1 equals 2x minus 1. So y equals 2 times x minus 1 plus 1. So I'm moving that over. If I keep multiplying through, or you could leave it that way, but if we're going to check it on the calculator, it's better to distribute. So that's 2x minus 2 plus 1. So my tangent line is 2x minus 1. So I just found the tangent line at the point 1, 1. So I graph this, and on my graphing calculator, so let me figure out, this is the one I graphed. I just want to show you, after you graph it like this, remember, if you hit menu right here, analyze graph, and then hit dy dx, if you put the point, if you put 1 in there, just hit a 1, hit enter, it's going to tell you the slope at 2. The slope is 2 at 1. And then if you want the tangent line, this is just to refresh your memory, hit menu, geometry, points and lines, and tangent, and then you hit this point right here and it'll tell you the tangent. So I had class actually graph this and have all the answers first. They already knew the slope was 2 at 1, and they already knew the tangent line, so that when you go to do your algebra, it justifies everything we found. So it makes you happy and you realize you did it correctly. All right, the next one I'm going to do is 4. It's very similar. I'm just going to kind of get you started on this. So I had everybody graph this. So y equals x cubed, excuse me. So if you come here, I just did this one's the next one. So I said, here's y equals x cubed. And they want me to find on the graph y equals x cubed at the point, which was this one, 54. Oh, okay, at when x is 2. So I did that. I did exactly the steps I did last time. I found when x is 2, the slope is 12, which is pretty steep. And then I found the tangent line, just going through the same steps I did. So I already know the slope is 12, and I already know my tangent line. So that makes it nice. You just have to make sure you show me the calculus to justify that. So first thing I'm going to do is, if I know x is 2, if I plug a 2 in there, I know my y is 8. So I need my point. So the point 28 is going to go there. So I knew that part. Now I just got to find the slope, which is going to be my first derivative. So I do f prime of x equals 3x squared. And now I want to find f prime at 2. It's 3 times 2 squared, or 4 times 3, or 12. There's your 12. My slope at the point 2 is 12, my rate of change. So now the 12 is going to go there. So I have y minus 2 equals 12 times x minus 8. And I have those backwards. That's not right. Let me go through. I just did that backwards. That's what happens when I think I'm rushing. So I'm sorry about that. So now the 2 goes here, and the 8 goes here. So I have y minus 8 equals 12 x minus 2, and then y equals 12 x minus 2 plus 8. And if you continue to go through and do that, you will end up with the tangent line I showed you. But this is good enough for me right here if you want to leave it just like that. But if you are checking this on your calculator, you might want to continue to do that. So that's 53 and 54. So make sure you know how to do one of those. All right. The next one I'm going to do is 57. Okay. So 57, what they want us to do is, it says, on what intervals is the function f of x equals x to the fourth minus 4x cubed both decreasing and concave up? So I kind of copied that down. Then I talked about, okay, my function is decreasing. What is that? What do I need to know? Well, that's when my first derivative is less than 0. So my f prime of x is got to be negative. And concave up is my second derivative. And because it's up, it's got to be greater than 0 or positive. So we actually graphed this in class. And I'm going to show you the graph in a minute. But I wanted to show you how I set this up. So I really haven't done any math yet except set everything up. That is a sketch of this graph. I mean, it's a sketch. Here's x, y. And I kind of drew it, and I set up the f prime bar and the f double prime. And I want you to be able to do that. And I want you to make this bigger than your pinky so that you can label things. So I actually graphed this here as well. Let me see. Let me get back to it. So that's my next graph. And I had to play with the window a little bit to show, because do you see how this goes down pretty far? And I see that it's kind of decreasing here, concave up, flattens out a little bit, but it's still decreasing some more. So I've got a couple turning points here, and then it's increasing. So having the graph there is going to justify all the work that we're going to do. So let's do the work. The first thing is you do your first derivative, because that's the increasing and decreasing part. And when I do the first derivative, after I'm done, I'm going to set it equal to 0, because that's when my turning points in my graph have a slope of 0. So I have f prime of x equals 4x cubed minus 12x squared. So basically, the math is not that hard. I just want to make sure that you understand the concept of it. So now that I found the first derivative, what I want to do now is actually put it equal to 0 to find the turning points, to figure out where the changing of the increasing and decreasing go. So I'm going to put this equal to 0. When you do that, I want to kind of solve for x. So don't forget your your skills of factoring. I can take a 4 out of those, both of those, and x squared, factor those out. So when I do, I have an x minus 3 equals 0. Draw your big T. 4x squared equals 0. Yes, show this part. X minus 3 equals 0. So x is going to be 3. And if I divide by 4 and take the square root, x is 0. So here are the 2 points on my graph where the slope is 0, or my turning points. So I'm going to come over here, and right here is where it's 0. And that 1, 2, 3 is a turning point. I'm happy because my sketch isn't too bad, because this looks like it has a slope of 0 here and here and here. So it's almost like you're justifying by looking at your graph, but it's the algebra that tells you that. Now, this is the part that I want you to watch me. This is a number line, the F prime bar. It's a number line. I want you to tell me when it's negative and positive to find out when my function's increasing and decreasing. You can look at the graph, but that's to justify. So I want you to look at this factored portion of this. And I'm going to do a number. I'm going to pick a -1 because it's on the other side of 0. When I throw in a -1 here and a -1 here, when I square -1, it turns positive times 4. So this is positive. When I put a -1 here, that's negative. A positive number times a negative number is negative. Okay? So it's negative here. My function is decreasing here. I look up, yes it is. Okay? Now I'm going to try between 0 and 3. I'm going to use 1 because it's easy. So I'm going to take a 1, plug a positive 1 here. This is a positive number. Plus a positive 1 here, that's a negative. A positive times a negative is still negative. So I look and say, yes, my function is still decreasing. So it justifies what I'm finding. Over here, I'm going to plug in something on the other side of 3. Let's pick a 4. If I put a 4 and square it times 4, that's positive. If I put a 4 here and subtract 3, that's positive. Positive times positive is positive. So my function is increasing. And there I go. It matches my graph. I'm happy. Now the next thing I'm going to do is F double prime, because I got to talk about concavity. So F double prime of x, come back to the black here. So I've got 12x squared minus 24x. Like I told you, the math is not bad. Now put it equal to 0 because that's where you're changing your concavity. These are called inflection points. So now I'm going to actually factor out a 12 and an x. When I do, I have an x minus 2 equals 0. Big T, 12x equals 0. X minus 2 equals 0. X is going to be 0. And x is going to be 2. All right, so this is the change in concavity. So I'm going to come over here on my F double prime bar. I'll use purple this time. And at 0 here and at 2 right here, so 0 and 2 are where my changes in concavity are. Now to check this, go back to the factored form and start plugging in numbers to the left of 0, in the middle of 0 and 2, and to the right, and use easy ones. So I'm going to use a -1 here. If I put a -1 here, this is negative, that's positive here. Whoops, that doesn't show very much. So this is going to be concave up. Let's look at the graph. Yes, it does look concave up. These are positives here, guys. You can hardly see them. Then we're going to do between 0 and 2. I'm going to pick 1 because that would be easy. If I put a 1 here, this is positive, this is negative, so it's going to be negative in the middle. This is concave down. And this does look concave down for part of it. And then from 2 and above, I'm going to throw a 3 in here. Positive, positive. Again, this is concave up. And I look, and it is. So that's all good and very colorful. But now we have to answer the question. They want to know, when is my graph decreasing and concave up? Okay, so where is it decreasing and concave up? Well, it's decreasing and concave up, and I'm going to use yellow here, decreasing and concave up here. And then where else is it decreasing? Oh, it's right here in this little thing between 2 and 3. So my answer, all right, so my graph is, my function is decreasing and concave up. So they have to happen at the same time. From negative infinity all the way up to 0 in union with 2 to 3. Those are the intervals that my graph is decreasing and concave up. All right, so that's 57. Now, when you do 58 and 59, they're very similar. Make sure that you look at this. I've done notes on this before, but I just want to make sure that you're comfortable with this and that you're showing all the work to justify what your graph is doing, okay? Now we're going to work on 61 and 63. 61 is kind of a short one. It talks about a sand dune. And so let me read it to you. It says the height of a sand dune in centimeters is represented by this function f of t, where t is measured in years since 1995. Find f of 5 and f prime of 5. Make sure you use units and explain. So this one's more of an explaining. So I wrote the function down and I labeled the crap out of it like I told you. This is my height in centimeters, and this is my time in years since 1995. That's what T stands for. Now, if I do f of 5, so we're going to do f of 5. If I throw a 5 right in here, I've got 700 minus 3 times 5 squared. When I do that, I get a beautiful, beautiful number of 625. So what's important to me is, what does that mean? That's very easy math. Well, first of all, if I'm doing the function, if I throw in a 5, I'm talking about time. And when I plug that in, this is going to give me the height. So this is really 625 centimeters. Well, if I was going to explain what this really meant, this means that 5 years after 1995, or in the year 2000, the height of the sand dune is 625 centimeters. So that's important to me, that you know what that means. That if I take the function, plug a 5 in there, that's what that means. Now I'm going to do f prime of 5. I don't know why I wrote a double prime there, sorry. So I'm going to do f prime of 5. First of all, I've got to do f prime to do that. So I'm going to do f prime of t right before it. F prime of t is going to be negative 6t. Because when I take the derivative of 700, it's 0. If I take the derivative of negative 3t squared, it's negative 6t. Now, if I plug a 5 into that one, it's going to be negative 6 times 5, which equals negative 30. Now, what's important to me that you know, that when I do the derivative, this is a rate, or like I started out the year, this is slope. Okay, if it's a rate, you're going to use units, and in slope, it's something per something. And I'm like, what would that be? So I have, I've got years in centimeters. That's negative 30 centimeters per year. So that means that's the rate, and because it's negative, it's decreasing. So it must be the wind's blowing, because my sand dune is going down. And in this case, it's still the year 2000. So it's telling you something different. It's not telling you the height. It's telling you in 2000, okay? Basically, you're saying in 2000 to 2001, because it's 1 year, right? That's centimeters per year. The sand dune eroded or decreased, but let's use a scientific term, 30 centimeters. So it went away 30 centimeters. Or you can say in the year 2000, it decreased 30 centimeters per year. But it's a rate. So they tell you different things. So that's why that was interesting. And I wanted to make sure that you're good with that. And the last one I'm going to do today, I'm not going to take too long on this. I'm going to kind of get you set up. But 63 basically is a whole thing. And I don't know why I throw fruits and vegetables, but it says at time t seconds, after it's thrown in the air, a tomato is at this height of this function, negative 4.9 t squared plus 25t plus 3. meters. So they want to ask some questions about it. So I did a little sketch because life is in quadrant 1. I know this is a quadratic, it's negative. And if I put 0 in for t, I see that it's thrown at 3 meters. And I labeled it my height in meters, my time in seconds. And so I know this tomato is going to go splat right here and it's going to hit the ground. Okay. So let's talk about average velocity. If I wanted to find average velocity, first of all, you got to recall that velocity is your first derivatives. First derivative. So I'm going to say I'm going to find the average velocity, and they want you to find the average velocity of the first 2 seconds. So I'm going to actually do time is 0, time is 1, and time is at 2, the velocity, and average them. Okay, so first of all, we got to find what the velocity function is. So I'm going to do that right here. F prime of t is 2 times negative 4.9, so that's negative 9.8 t and plus 25. So there is my velocity function. F prime of t is my first derivative. And now when I want you to plug in f prime of 0, right? F prime of 1, and then you're actually going to do f prime of 2. So you're going to plug in for all of those when you do that. So if I do this for 0, I got negative 9.8 times 0 plus 25. So this is going to be 25 meters per second. I'm not going to label it quite yet because I'm running out of room here. And then this one, I'm going to plug a 1 in. So that comes out to be 5.4 meters per second. And then I'm going to do, that's f prime of 2, sorry. I'm not going to do 1, I'm just going to do f prime of 2. Well, I'll make that a little bit easier, so I'm going to erase this. We're going to do 0 and 2, so I'm not going to do it at 1 because if I averaged it out, it'd be the same. All right, so I'm going to do here f prime of 2, and when I do, I get 5.4. So then if you take those two, the 25 plus the 5.4 divided by 2, my average velocity is 15.2 meters per second. And the reason why I did that is because I said the word average, okay? If I wanted to know the instantaneous velocity at time equals 2, well, that's easy. We've already done it. It's right here. At f prime of 2 is 5.4 meters per second. So they basically want you to notice the difference. At 2 seconds, instantaneously, it's 5.4 meters per second. But from when I threw it, from time 0 to time is 2, the average velocity was actually 15.2. So there is a difference from instantaneous and then average. Now they want me to do the acceleration at time equals 2. So I'm going to go back up to the velocity equation, which is right here, which we just found, right here. And I'm going to do the derivative, second derivative. So let's pick this one. F double prime of t is going to be just negative 9.8. And because it is a second derivative, it's meters per second squared. And those of you that are physics people know that's acceleration due to gravity. So that's my acceleration, all right? But now I want to find it at 2. Well, it doesn't matter what I plug in here because it's a constant. When I plug a 2 in it, it's still negative 9.8 meters per second squared. So you got to be careful with the units because I did another one. So this was meters per second. This is meters per second squared. Now they ask, how high does a tomato grow? Now this is where this is a little bit different than what you've done in pre-calculus, because now we know that when you have a turning point or the high point of your graph, we'll look at where I threw the tomato. Right here, I know that my slope is 0. So if that's my slope, I know if I take my first derivative of my velocity function and put it equal to 0, I can find out when that actually happens. So we're going to do that a little bit differently than you've done before. So what we're going to do here is take that velocity equation, which is negative 9.8 t plus 25, put it equal to 0 because that's where the slope is 0. When I solve that, I get negative 9.8 t, 9.8 t equals negative 25. So t actually comes out to be 2.6 seconds, which is nice to know. That doesn't tell you how high, but I do know. at 2.6 seconds right here. That's when it happened. So then I can take that 2.6 and just throw it into my original equation, my original function. So f of 2.6 is going to be negative 4.9. 2.6 squared plus 25 times 2.6 plus 3. That's my original function. And when I plug it in there, I'm going to get 34.4 meters. And that's my max height because that's when your slope is 0 or your velocity is 0. So that's my max height. So I'm going to come back up to my picture here and actually put 34.4 here because that's how high my tomato goes. And the last one I'm not going to do because you should be very good. They ask you how long it's in the air. This is a good question. So basically, I want to know how long it's in the air. And if you look at this, it's in the air all the way till it goes splat on the ground. So I want to find when my height is 0. So you're basically going to take your original function, and you've done this for years, and put it equal to 0. So you're going to take f of t and put it equal to 0, your original function, which is negative 4.9 t squared plus 25t plus 3 equals 0. So go ahead and do the quadratic formula. Are you going to stack and rack a equals, b equals, c equals, and your d equals? Throw in the quadratic formula and make sure you figure out what it is. If you do it when you're done with this, you should get 5.2 seconds, which is this doubled, roughly rounded, but I want to make sure that you do that. So I hope this gives you some guidance. Make sure you do the ones that I didn't do. And if you have any questions, make sure you get back to me. So this is the end of this video. I'm sorry if it was a little long. I just wanted to make sure that I helped you out.